is your first name. All right. Khalifa, your first name. Yes. Farad, also. Yes. Nathan. He. Is it okay to call you he or Ong? Z. Z is a last name. Ah, sorry. Then we should change this. What is it? E G N G N G. Okay, he is a first name. E G. Okay, good. What you? Mohan, Junho, right. I'll change this one. All right, and you get this one. But it is very tentative one. I just write down your name somewhere, but it will change. Last night I just make this one. But this one is very similar to the 1 year ago. So I just copied and changed some of. And this is it was a special lecture by another professor. And sometimes this one means late evening class. Because of my trip, sometimes I go to abroad by using this video and online teleconference tool. I found that that's better using teleconference instead of delayed lectures, some rescheduled one. So nowadays I prefer to have one, but depending on the time difference. So this time I have a plan to go to France, Toulouse, in May. So at that time I found that 1 o'clock is not good for myself. So I may try, say, 7 o'clock in the morning. Then you may be, what time is it? 8 hour difference. So it's 5 o'clock something. Anyway, we will find out the proper time. Right? And also sometimes we need replacement hours. So that is the case of when you rescheduled time or day. So we will find out today makeup class hours. Something like this one. You will find out available time slot of the whole week of 9 people. Right? I guess your schedules are class schedules are fixed. We'll do that. This one today. And also introduction of students. You will have 1 minute, everybody, to introduce yourself at near break time, after 30 minutes or 40 minutes. All right, so this is a project proposal presentation, midterm exam. Right, this is one exam proposal, special lecture. All right. And this one I will have a plan to visit Toulouse, France. So we'll find out proper time. Fortunately, if we do this way, then can be one class can be a midterm exam. Do you have the exam week? Can you check whether is it same week as this one, or the whole university has a 1 week of exam, right? Midterm exam period. April? Really? Then we can do let me find out, because my schedule usually I do on, say, after 10 weeks of classes. Oh, this is a midterm presentation rather than midterm exam is in here. Right. April assumption. Right. Sorry. Right. Okay. Right. So we will change this one. But anyway, you will do this way. So I hope TA starts to show how it is operating. So next week, Monday, TA Kijong will lead your discussion time. After, right. Midterm presentation is a term project presentation. Term project is a project proposal. This is a written exam. This is project, term project. Term project. But these one are classes, lecture, similar to myself, lecture of chapters of the textbook. Yes. Homework? How much? How much time per? Sorry, say again. Usually, I give you 2 weeks time until the submission date deadline. Same as myself as a lecturer. Right. And I will provide the previous PowerPoint file, old one, so you can update that one or as cooking as you like. Right. And also you can see the previous year's lecture video. There are also student lecture video too in YouTube, so you can see how do they. It's similar as a lecture. I'll provide the old material to you. Okay? Any other question? Yes. Right. Right. Amount of lecture you fit to the time slot rather than amount of slide. Right. You finish by 25 minutes. We have 75 minutes of class, right? Per day, right? So I divide them into 3 parts. So each one is 25 minutes. So 25 minutes of my lecture, 25 minutes by student lecture, 25 minutes by discussion led by student. Every day. That's why I have 3 names per day. Right? 3 names per day. My lecture, student lecture, and student discussion. 20, or each one is 25 minutes. Yeah, that's better. Right. Usually do that. Well, I ask you to find discussion topics from the lecture note, but actually it does not work. they prefer to bring his own topic. So you can see from previous website the samples. Probably 1 or 2. It's up to you. You can ask to me anytime because I have one, right? But usually they do very shortly, so they don't need earlier. 1 month ago, 1 month before, no. So I usually provide 1 week's time, but if you want, I can provide now. But schedule is changing, so. 모범을 보이시라고. 네? 이따가 얘기하시죠. Right. Any other questions? Yeah. 뭐가요? No, it was a sample. Yeah. I can do on this day, currently I can do on daytime. This is not quick. It's term project. Anything about ocean engineering and naval architecture. I provide you samples of previous semester. At the first lecture note and video, you can see it. You can download the first lecture, right? Introduction to the class. At the end of the slide, there is a sample term project which was done several years ago or last year by student. So that can be a sample. That was one slide from I copied from their presentation. Yeah, project presentation, term project. 3 presentations. Yes. So discussion is also presentation. Discussion. I hope you talk much communication discussion. But should there be also PPT? Usually the leader provides several slides because he wants to initiate the talk discussion. So usually the leader bring questions. So basically they're very similar, right? No. Lecture is one way, right? Discussion is 2-way. Right? So I recommend students to bring something topic that can be debated. Right? Half of the students is agree, and half of the students not agree. That kind of topic is good for debate, right? Discussion. Not a lecture like one way introduction or explanation. Discussion. So debate. Once I try to have a real debate to make a party, make 2 groups, and then you are assigned to be agree, and the other side is assigned to be not agree, and then try debate. But it takes more time and effort by yourself. So I just recommend you. So try to see the previous slide. All right. Okay, let's try. I provide you this one, right? Last night. You threw the KakaoTalk. Yeah. Do you have any problem using KakaoTalk and downloading files? No, it's okay. Right? I stopped here. Right? Then we can continue. Oh, it's almost same one. Oil deposit. Right. So that can be an old picture probably. Does not show any oil from ocean. Right. Only it shows land and also near shore. Right. Near shore. Some ocean part is here. Right? Ocean. Some of the ocean part is here. Right. And Gulf of Mexico. Oh, many. Right. But now things are changing because of the gas coming from
shale gas. But map can be redrawn. And this is a development picture. See, this is a very big picture. You can see that this one is the offshore structure. Size of, say, several hundred meters length. Right? 200, 300 meters wide and breadth. This one. And then Korean shipbuilders are building that kind of thing by a contract like $1 billion per project, per unit. So it's a big one. Then see that the cable is a pipes, right? Pipe. And then subsea under the ground, say 1,000 meter depths, depending on the sea, ocean. There is a wells, similar to the land site drilling of water or oil. Right? Oil is coming or gas is coming, and then they collect small productions into a large one and then collect it. So it's a something like a production rather than exploration. Okay, they say they are processing and subsea unit, and then riser. It says a pipeline, flow line, pipeline, and riser is something like a rising part of the pipe we call riser. This is a seabed floor pipe, but it goes up to the processing unit. This portion we call this a riser. And this is a fixed or floating structure, offshore structure. It looks like a floating one, this one. Drilling at the bottom, see there is a drilling bit, right? It drills soil and rocks, right? So this should be strong enough, right? And casing and riser, it says it is rising. Oil is rising or gas is rising, so it is a riser. And then this is a bottom of the top of the seabed. So this is water part. And then there should be some coverage. Blowout prevent. This is very important. At the Gulf of Mexico, there has been a big disaster, explosion, about 5 years ago, more than 5 years ago. Very big explosion there, Gulf of Mexico. It was an operation by British Petroleum, BP. So they had a big damage by this explosion. And the burning oil was about more than months. Explosion and burning for a long time. And that reason was one of the problem of this part at the time. Right? So complex, right? Complex. But anyway, simply this is drilling, right? And the others are supporting material. Drilling and production oil and gas surface platform. Surface platform is something like this one. What this means is water surface. And drill pipe. The pipe is produced by the pipe maker using steel plate, right? They rolling and probably welding to make a pipe. Pipe size is something like this one. Not so big, right? Something like this. Not in this way. Something like this way. And then it is a finite length. So they purchase pipe and they do connection to the depths of several kilometers down. Right? So they call this a drill pipe. And also drilling fluid, they provide some lubrication, water. Usually water is used, but lubrication is needed for the drilling. And then casing, riser, and drill bit is the final stage. We'll see more in the later stage. Oh, there's a video. Okay. It's not very good. Then, sound. Okay, sounds good. Seven minutes.
When the vessel arrives at the drilling site, it receives a satellite signal that helps the vessel move into the exact position required. The vessel has 6 propellers that rotate a full 360 degrees and keep the vessel in one position, preventing it from drifting due to the wind, waves, or sea current. First, the conductor pipe is installed. As the drill pipes are connected, the conductor pipe and drive are run down to the seafloor. After the conductor pipe penetrates the seafloor, the drill pipe is released and pulled back to the vessel. A large drill bit connected to the bottom of the drill pipe is run down to the seafloor. The drill bit is let down to the bottom of the hole through the conductor pipe. The drill bit rotates and drills the sediment and rock below the seabed. Seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back to the vessel. A casing pipe, about 50 centimeters in diameter, is set into the drilled hole to keep it from collapsing. The casing pipe is run down through the conductor pipe and is inserted into the hole using the drill pipe. Cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. After cementing, the drill pipe is released and pulled back to the vessel. The Chiku is equipped with a riser system in order to drill into the earth even deeper. As the riser pipes are added one
So
after
they
another,
provide
the
many
is run down
pipes
to the
and
seafloor.
connect them together to give deep inside. So each piece is one provided by the
wellhead, which is located on top of the casing pipe. The vessel is now connected to the seafloor via the riser pipe. A drill bit, smaller than the one first used, is run down through the riser pipe and casing pipe.
Okay, that's enough for today. So you can see more if you like. Right. So you can get the idea. And types, offshore drilling systems, there's a jackup drilling rig. Jackup is something like a tower. So they have a footage on the ground. And semi-submersible is a submersible is something like a submarine. But they are saying not fully submerged, so it's a semi-submerged one. And then drill ship. Drill ship is almost like a ship, but has a tower on top of the ship so that they can provide offshore oil and gas production. platform. Fixed type is same as a jack-up. Fixed type jack-up structure, jacket, and gravity structure. We'll see the pictures later. And also fixed means footing is fixed, same as land side. But as the water is deeper, we need to have a floating type. And there are several different ones: tension leg platform, guy tower, articulated tower, single ankle leg mode, and FPSO and SPA. Many different types. So we'll see that. This is jack-up fixed platform, right? So it's the longest one. And then tension leg platform and SPA looks similar. And then semi-submersible. This is a squared shape, but has a supporting structure by, this is we call the submersibles, this part. And then FPSO looks like a ship. And pipes are here, and subsea structures there. And then number of offshore platforms worldwide 10 years ago. Fixed platform water depth is up to 1 kilometer. No, it's a feet, not kilometer. Looks like a feet, or it's a feet water depth, right? Okay. So water depth is, so it's less than 1,000 meter, right? It is about 400 meters something, 400 to 500 meter depth. We use fixed platform. You think about tower of 500 meters. It's very long, right? Say I calculate this one floor as 5 meters, right? Then 500 meter means 100 floor building, similar to highest building in around each nation, right? Lotte Tower, second Lotte Tower is 105 floors, right? So almost similar. And then compliant tower looks similar, and tension leg platform, and spars type, but semi-submersibles are many, and FPSO is floating types. FPSO is popular nowadays, and water depth is different, almost say more than kilometer, right? 2 kilometer, about 2 kilometer. Subsea tieback is a component of this, not a platform. And jack-up looks like this one. Long support leg. This is a leg, right? That can be raised and lowered because of the transportation. This one is on the transportation over the sea. Say that was constructed in South Korea and moved to the, say, Indonesia or East Saudi Arabia, right? And for the transportation, you need to have jack up the legs. Leg is something like 500 meter, so it's not good to undersea, right? So it's going up above the water, like this one. And then at the side, you lower down. So we call it jack up. Yeah. Something like an elevator. And then they find the footage there, fixed. So it's a towing condition, towed or self-propelled, but usually they towing onto the location with its legs up, and the legs are jacked down onto the seafloor upon arrival at the drilling site. And it can be only placed in the relatively shallow waters, generally less than 120 meters. Question. Fixed platform, similar, right? Jackets also. And gravity platform is like this one. This is famous one. made by Norway, several tens of years ago. It's made of concrete structure. And this one has a heavy tanks so that they are submerged. But once they built, they transported it in this way, the floating way. And then this one is concrete tanks. So they, at the site, they put water inside. So it is submerged down and stay there and operation there. Well, structure over there, this one is same one. Right? So it's submerged down, and then on top of these pillars have a structure that is for the processing unit. You can say factory, right? Refinery factory, processing unit. We call it. Processing, something like processing. Built on concrete. This one is built on concrete. Right? This is made of probably a steel, or concrete or steel, right? Or both. Anchored directly onto the seabed. Seabed. Supporting a deck. This is a deck. Right? Deck with space for drilling rigs. So you can do some operation. This is a hotel facility where the personnel members are stay there. But this is an operational unit for this. You can say it's a factory. Designed for very long-term use, sometimes immovable. Say you can do floating again, but usually it can stay longer, right? Because the operation is very complex. Also, the top side is heavy, so it is not easy to move. Installation depth 500 meters. Tension leg platform. This is something like a floating one, but there is a very strong line, tying lines there. So this is we call tendon. They so call this tendon, right? Or tether or tendon. This line looks like a line, but this is a strong wire line. Mooring word is stay still by we call mooring. It is also used for the ships. When ship is arrive to the port, they should be stay still, right? It should not be moving at the port side, so that they put lines, right, and anchors and lines, many lines, to stay that hold it down, and then operational side, container cranes are moving. So we call this as a mooring, but special kind of mooring. We call the tether and tendon. Structures known to be economical between depths and eliminating vertical motion using large tensile force. So this one looks like this is a footage. Should be strong enough, and then along this line, tension is going on. High tension. By providing more floating buoyancies going up, floating, right? Then it is going to be a tension, right, along this line, so that high tension, so that structure is moving, but very small moving, because of the wave and because of the wind, using high tension. So we call this tension leg. Eliminating vertical motion, because wave is coming, the ship is moving up and down, right? So they don't want that one, because I want to drill down. Drilling is going on, so that platform should be stay on position. Large tensile force from high axial stiffness tether. This is tether, right? Installation 2 kilometer. 2 kilometer means the water depth. And this is also another video. No, it's only picture, right? No video. It's video. Oh, it's a video. Okay. So you'll see here shortly. Quality is not good. Anyway, you can see the tether. This is a structure above the water. So this is a tether, right? Tension leg is here. This is a drill pipes unit. The tension leg is this. Okay. All right. The tension leg is here, tether. All right. And submersible. Submersible looks like this one. Right. And see that there is a paint different colors. So this is looks like you show the draft line. Water line is here. Right? So this is any floating structure, including ships. They have a clear line for the safety reason. Right? Do not use ship above this line. Right? Overloaded line. So we call this draft line. So you can see that this one is only above this part, right? When submerged. And then this part provides support, floating power to support this above structure. This is a heavyweight factory, but that buoyancy is coming from this submerged part. Obtaining buoyancy from ballasted watertight pontoon. We call this is a pontoon. And ballast means ballasting is water inside or outside, empty or filled. Right? Before we saw this is this one. This one is concrete cylinders empty, almost empty, so that this whole unit is floating. When the location is arrived, then they are, we call filling with water. We call this as ballasting. Ballasting, how much? We should be designed amount. We have a calculation, all the calculation, designers should calculate. So we call it ballast. So in a ship, there is also ballast tank inside. And for the Koreans, the Sewol case, the accident, ballast water was a problem. So for the ship, Sewol, same as ship was a passenger ship at the time. Propeller, but there is a high superstructure of hotel facilities. Right? As I told you on this Monday, the ship, the Sewol, was imported from the Japan as a used ship, and they renovate the ship. But when they renovate, they put another layer. This one is added, another layer, to provide more rooms. Room means money. Right? So that for the stability, they are required to put more water here. We call this is ballast water tank. Right? To cancel, because of the weight is going up of the one floor higher, so they provide more water at the bottom to balance and to make stability there. So we'll see in the later stage more about this. So I'm trying to explain about ballasting. Watertight pontoons, this one. Deeply submerged. It looks like not deeply, right? It looks like shallow, but because the size of the structure of several hundred meters, 300 meters, say, then the depth can be more than 100 meters. We can say they are saying a deeply submerged hull. And what is a threshold value of deepness is usually we call the length of the wave is coming. Wave of length, wavelength. In ocean always there is a wave, right? Short wave, small wave, but sometimes that comes with a high, big waves is coming. And structure should be designed to safe enough to when the high wave, big wave is coming. So that can be the design wave condition. Right? For the designers, you will see it in the later step. And then the length of the wave. Yeah, cosine wave, sine wave, right? You imagine this. Length, wavelength. One single cycle, wavelength. And that is finite, right? Number. And then deep water means it is more than this one. Right? So 100 meters is much. Right? Enhancing stability and reducing wave induced rolling, right? So once again, if the depth is higher than the length of the wave, there is no disturbance by wave. So when let me see. 가두리 양식장. How can I say in English? Fish farming, small size fish farming. There are many around the coast area, also in Korea. They usually have a cage like, so say 10 or 20 meter wide cage. And then fish is inside. They provide something to eat to them, right? But problem is when the storm is coming, typhoon is coming, because of the high wave, the cage can be break, or if not, the fish can be escape. So in that case, they submerge the cage. How deep? Several tens of meters, 20 or 10. Then, so you don't have a experience in diving, right? Scuba diving, nobody, right? So if you go down to the water, say 10 meter, 20 meter, no wave, no, it's very calm down there, calm water there. So this is a reducing wave induced loading. So if you submerge something more than the length of the wave, then the water is very calm there, no wave force. The idea is here. So it's a floating portion. The main body is submerged enough, right? So that wave-induced force is small. But problem is sensitive to load changes. That means, see, you can think of a submarine. You don't have an experience to on board of submarine. But submarine should be same as your body. I told you that your body is almost same special weight as water, right? That's why we can do divings. Right? You can do diving. If your specific weight is very light, then you cannot go down. If you try to use your what is it? Safety belt or something balloon, air tank on your body, and then trying to go down, you cannot do that. You cannot do that. But sometimes in reverse way, if you have a heavy weight on your body, then you cannot go above the water. It goes down, right? So sometimes in all the films that fix some stone and then you put into the water to kill the person. So submarine, whole submarine body is almost same specific weight as water. Right? To make going down and operational, you should go up when I want to do, and it should be go down when I want to do. So the specific weight is almost same. Right? So using ballast water, there is also ballast tank there inside any ship. Right? Then so I designed the submarine somewhat similar to this way. Right? But something is happening. I want to load 10 more torpedo than designed one. Then it can be weight, say, 2 tons, 3 tons. Per torpedo, it can be 500 kilograms something. Right? The commander want to bring 10 more torpedo than designed. But it can be a problem. Right? I'm saying this one, sensitive to load change. This kind of structure, because of the buoyancy is coming from here, and because the main reason is that, no, it's not written there. Water line area, we call it water line area. When the water is here, right, the sectional shape of the water is around this pillar, right? So waterline area, we call it waterline area, should be big, because if submerged, say 10 centimeter down or 1 meter down, then volume increase, right? And then buoyancy forces increase. Can you get this? water bottle. Right. If I put this one in the water, right, and then water line is around here, right, but I want to push it down more by force, and then go in this way by my force, right? And then what can be the force? The amount of water, I call this displaced water. Same weight of displaced water, it can be the buoyancy force I'm exporting. Right? So if you have a smaller diameter of this bottle, then it's easy to down. Right? If it's big, it's not easy to down, right? Because buoyancy is increasing fast. Same idea there. Right? We'll see more in a later stage. Anyway, they are saying sensitive to load changes, thus must be carefully trimmed and maintain stability. And trimming is something like this one is trimming. Anchoring, chains, lines, and ropes, and also use dynamic positioning. Dynamic positioning means there is a small, but it's not small, or looks small. There are many propellers. And then by using propellers around the structure and then positioning and also orientation, you can keep the position correct. We call this is a dynamic positioning. By using GPS, you should know where should I stay there. But because of the wave and wind is moving, right? So by calculating the difference, you control the propeller somehow, and then keep positioning. It's very similar to drone. Drone is staying one position in the space, right? By controlling the 4 propellers. Right? We call this dynamic positioning, keeping position. Installation depths. Question. Floating production, storage, and offloading. I already explained this slide, right, before. The processing. Processing is a factory. Storage in a tank, oil or gas, and remote area, deep water, because it's floating, not fixed type. And seabed pipelines are not costly. Pipeline up to the land side, not costly. So they can be easily moved because it looks like a ship, right? It looks like a ship. Box ship. Spa is very interesting structure. Very long, one big cylinder, right? Long and big cylinder. And then tension leg too. This is tension leg, but it's one big long cylinder that it provide buoyancy. But this one has something like a rotating stairways. We call this is spar. Consisting of large diameter, single vertical cylinder, this one, supporting a deck. Supporting means providing buoyancy forces, weight. Typically used in very deep water because of this long cylinder. This is more. You see that this one size is about 200 meters, 300 meters. So that you can expect this one is more than 1 kilometer. That we are saying very deep water. World's deepest platform is the Perdido in Gulf of Mexico, right, 2 kilometers. And interesting is this stair looks like a staircase, but it is not staircase. It is a fin structure to compensate water flow induced vibration. See, can you remember your hydrodynamic classes, elementary hydrodynamic classes? Vortice, when water is flowing around the cylinder, vortice is coming around, right? And separation, can you remember this kind of separation? Yes? Yes? No? No? Separation of hydrodynamic separation? Yes? No? No. Okay, everybody remember. And then vorticity is coming from at the point of separation, and turbulence is making noise. So because of big size, but still is similar. Right? So there's a vorticity create something forces and periodic forces, and it can make a vibration. And to reduce that kind of phenomena, they provide such a fin to make water is flowing in the other direction. Interesting topic there for the hydrodynamic people. Design condition. So we need to have a break time. Okay, I already passed 5-minute break, and then we will have your introduction of students. 1 minute each.